it's Mrs. Kavanaugh. I am attempting to do a science experiment that I actually saw, and I thought it was really cool, and I thought that I might try it on my own, and I've never tried it before, so this is very risky, but we always tell you to take risks. Here are the materials that I'm going to use, and you could substitute other materials if you happen to not have the ones that I specifically have. So here are our materials. As you can see, I have a very thin, pointy wooden stick. This is called a skewer. And for this purpose, I actually have an incense holder. You could also use a glob of Play-Doh. The point is for the stick to securely stick inside something like some clay, Play-Doh, maybe a ball of duct tape, and I have aluminum foil, I have some tea lights, and scissors, and a lighter. So, here we go. First thing I'm going to do is I'm going to take this and I'm going to cut it into a circle. Now that I've cut my aluminum foil into somewhat of a circle shape, I'm actually going to start from the outside, and I'm going to make a spiral shape starting from the outside and just keeping an edge on my circle, but I'm working my way towards the inside, and I'm continuously going to work my way to the inside of the circle. Once I get to the inside of the circle, I'm going to stop and I'm going to take a look at what I've done. Put it on the table, flatten it out just a tiny bit to see what you've done. See, you've made like a spiral type shape. I don't know if you can see that. Okay, take the center of your circle and you're going to wrap this now around, and you're going to just put the center of your circle in this hole. Well, you're not going to put it in a hole, but you are going to put it so it can easily glide around the top. I haven't poked it through the top yet. And I'm not going to. However, it should also be cut so the spiral is not touching the bottom of the table. The aluminum foil should be able to freely spin around the skewer, creating no friction at all to stop the aluminum foil from spinning. I'm not going to spin it though, the flame is, and heat is energy, and we're going to use heat energy to help this spiral spin. We know heat rises, and we're going to see an example of that right here. So heat is creating an energy to spin this on its own. I wonder if I add another candle, if it will spin even faster. And it sure does. So, this is an example of energy, heat energy, how heat rises, and Mrs. Jordan had mentioned that it also has to do with a word called convection, which I'm going to now pass it over to her so she can further explain more about heat. Thanks for watching.
Mrs. Kavanaugh, that was an amazing experiment, and thank you for doing that. what you were doing was showing us the laws of heat transfer, and you were exactly correct. You were showing an example of convection. And what you were doing is transferring the heat upward because heat likes to rise. Heat likes to rise because all around us are atoms in the air, in the water, in solids, and those atoms are in movement. But when they heat up, they get a little bit busy. And if they get warmer and warmer, they get a lot busy and they start bumping off each other, and then they start expanding and getting bigger and bigger and bigger. So when they do that, they get lighter, and that's when things will start to rise. So I'm going to go over here to my dishwasher, which I heard just beeped, and maybe Miles can come over and open it for us. And first of all, guess what's going to happen when he opens the dishwasher? Okay, so hopefully you have an educated guess of what's going to happen when we open this dishwasher that just stopped. Let's see what happens. Go ahead, Miles, open the dishwasher. Pull. Pull. Oh, I don't know if you could see that, but there's lots of steam. And where does the steam want to go? And it wants to travel upward because the atoms in here are bouncing off each other really, really fast. And the air is expanding and getting lighter and lighter. And when we open this, we release the air, and it's so light that it just wants to travel up. I'm going to show you a couple more experiments where we see convection heat transfer happening. Okay, so here I have a little bucket of ice water, and this glass bottle has been sitting in this ice water for quite a while. So the air inside this glass bottle is quite cold, and that means that the atoms are condensing together and they're not moving very fast. They're just sitting still. So what I'm going to do is put this quarter on top. You can see I have a quarter on top of the bottle, and I'm going to put my very warm hands around the bottle for a couple, hopefully less than 20 seconds, and we're going to see what's going to happen to this quarter, because my hands are going to be very, very warm, warming up the air that is cold inside here. So we're going to have an extreme change in the air temperature in here, so that atoms are going to start going really, really fast and bouncing off each other again, and the air will start rising because it will be less dense. So think about what's going to happen to that quarter when the air starts rising up. Did you see that? Did you see what happened to the quarter? The air was really, really light because it was less dense and warmer, and it was rising up, and what did it do? It made the quarter pop up a little bit. The quarter didn't do that by itself. It was the convection of the heat exchange. Pretty cool, huh? You could try this one at home. So an example of convection in nature is when we see birds that are soaring through the air, and they are using the warm air to help them lift up higher and not use their wings to flap and use their own body energy. They're using the heat transfer, the convection of those warm currents in the air to lift them up.